No, you can do what? Where that recent you.
Today's the 18th. I should scroll up and head my notes. Oh, apologies. Today is the 18th. And we are going to start looking at inverses, but very specifically graphically. And we're going to use a little bit of technological assistance today. I know I will. I'm going to use Desmos. I do not want this to become a lesson on graphing families of functions. Like that's a different week altogether where we like look at how to graph a cube root function or things like that. I don't, that's not what I want this to be. So all of that heavy lifting as far as making a graph, we're going to use technology for that. And we can just use Desmos. I don't want to check out calculators today, but this would be a decent time to have them. Desmos is better, quite frankly. It's so good. Anyways, we're going to start with a function like this. And what we're going to do is we're going to invert it. If you don't know what I mean by that, I mean we're going to find f inverse. And so to invert this function, you've practiced this skill before. What do we do?
Swap that.
Swap them first. And that's really at the heart. When all this comes together to finally like really legit make sense, you'll understand why we do that. I showed you a little preview of that the other day about why we do that. And it was when you switch x and y on the other side of this, you wind up with x equals y to the third minus 4. And after you do the swap, then you just go into like attack mode where you say, I'm going to do whatever I have to do to get y by itself again. So what are we going to do? We're going to add the 4 across. So we're going to have y to the third equals x plus 4. And then what's the last step? We're going to cube root the whole thing. So we're going to make our final statement that we're going to say, I'm going to switch back over to this side of my notes, and I'm going to say then that f inverse of x must, oh, sorry, I should finish the job over here. So yeah, we're cube rooting this side and we're cube rooting this side. So I can make my final statement and then say that f inverse of x is equal to the cube root of the quantity x plus 4. Okay. So once we know how to graph families of functions, once we go through our little 1 or 2 week unit on graphing families, then we'll be able to do this kind of thing manually. But what I'm going to do is I'm going to turn this over to Desmos. And again, let the technology do all the heavy lifting for us. So you guys use Desmos pretty regularly, I would assume. I know Mr. Manlove was a big fan of it. Are you guys familiar with like the layout of it and everything?
Yeah, I use it for like college algebra.
It's I don't have any words to describe what a gift it is. Like then the people that made it, they're not advertising or anything. This is never about anything other than just uh helping people understand the colors and language of math. It's just so brilliant. Anyways, what I'm gonna do, and then you'll eventually be doing this on your own. But what I'm going to do is I'm going to graph the functions. I'm going to ask Desmos to graph the functions. So my first function was x to the third power minus 4. So you're familiar enough with Desmos that you understand the layout of this, right? And so that's what the function looks like. Now, from your notes, we did his inverse. And what was the inverse of f?
X plus.
Cube root, and I think that's CBRT, right? So cube root of x, and then the plus 4 is inside like this. And these two graphs, they might not look anything significant to you. But today, what I want you to really walk away from this with, I mean, it's just a short day, so I thought I could get this one mission accomplished. So I want you to really get your head around what it means for two graphs to be inverses. And do you know why these are inverses? Could you tell me based on our limited experience? Yes. So that little thing I said the other day must have stuck with you. What I want to do now is ask Desmos to just graph the line y equals x. So the green line is the line in mathematics that separates inverses. It reflects, I should say. So inverse functions will always reflect about that green line. It's essentially a mirror. And you can see that any point on the red graph can be mirrored perpendicularly directly across the mirror. So like, for example, we would all agree that um, Oh, that's way too fat of a pen. Holy Toledo. We would all agree that this, can you see that red dot right there?
Yes, sir.
That point is at -5, -1. Well, his kind of his homey point, if you will, is right here. And you can see that those points are in perfect mirror reflection from each other across the line, right? So let's take a quick second and study their coordinates, because this is really what you're going to be doing today is playing around with coordinates. What are the coordinates of this point? -5, -1. And all you simply have to do, it's a very literal understanding like thing. Like to invert, you literally set x equal to y. You know, if two things are equal to each other, you can swap them at will whenever you want to. So if x equals y and I swap their locations, the coordinates of this point, you can clearly see it matches our -1, -5. It's a very literal sort of thing. Like you can't not see that they're just switched. Boom. And that goes for any point. So like here's another example up here. What are the coordinates of that point right there? You see up here?
2, 4.
2, 4. And then if you switch 2 and 4 and you go to 4 and 2, 4, 2, boom, as expected, there's a point on his inverse. The goal of those 8 minutes of our time together was to show you like legit, this is like real. We took a function, we used our mad algebra skills, we inverted it algebraically. We asked a computer to graph them, and we can see with our own eyes that that's pretty legit. They're inverses of each other. What Desmos is going to have you do today is find the inverse by simply not doing any real, sorry if this isn't insulting. It's just kind of a drive the point home kind of assignment. It's going to give you a graph and ask you to do the inverse, and it's going to ask you to graph at least 5 points. So let me show you really quickly what it looks like, and then you guys can get to work. I want you to get it done before you leave. That should be the goal. So this is what the delta math will look like. I gotta clear this page off here. So the name of it, what I chose was identifying inverses graphically. And so here is it's not a function, right? It's a relation. So we can invert a relation. And what we're going to do is just pick 5 points. And you might already have an idea like of what it's going to look like. It's kind of good to try to generate it in your mind, like before you actually make the points and like bring it to life. But could you tell me like where the vertex is going to be? Let me zoom in for you. I apologize. I should have thought of that sooner. Do y'all see that graph there? So like, what are the coordinates of this vertex here? So switch 4 and -4. What would you say? -4 and 4. So you can quite simply go to -4, 4 and put a dot. And Desmos is very specific in the directions. It's always going to say you have to plot at least 5. It's always going to do that. All right. If it were a straight line, like a linear function, it would probably say at least 2 or 3. But because these are curves, quadratics, cubics, cube roots, weird stuff like this, we need more than 3. So let's pick another one. Someone give me another point that I could graph that would be on the inverse.
That's 0, -2.
So this point right
0,
here is 0, -2. Switch them. What do you get? So you just boom, switch them, go again. And you'll kind of see it start to take life before it completes the graph. Give me another one.
0, -6.
0, -6 is a point on this graph. So what would his homie counterpart be?
-6, 0.
-6, 0. Good. And if you already sort of theorized what the graph is going to look like, you can see it starting to happen. You can see that when something rotates about a diagonal line, it effectively turns itself like 90 degrees, right? 245s to get to the line and then away from the line. So neat. But I need 2 more.
-1.
-5, -1 is a good one. So I would do -1, -5. Boom. And then I need another. How about this guy? 3, -3. I like that one. And if I switch those to -3 and 3, I'll just go here, here, and then the graph takes shape. Desmos will auto-graph it once you click the 5th point. But that's the fun of it is like I mean, you could just ghost your way through this whole assignment, just kind of sleep. But try in your mind to think about like using your finger like on your Chromebook screen. Try to picture what you think it's going to look like. And then as the points come in, you kind of pat yourself on the back and say, yeah, nailed that. I knew it was going to look like that. So I put in the assignment for you guys to do a dozen or so of these. And then when you're done, all you got to do is just hit submit, boom, and it checks it for you and moves you on to the next one. Okay. And you'll see some different families of functions, quadratics, cubics, cube roots, square roots, whatever. It doesn't matter because we know how to invert.